Welcome to the SaberRD online training course. This series of fast-paced videos will quickly teach you the full power of the SaberRD simulation environment. In this section, we look at modeling with StateAMS. Circuits in SaberRD consist of elemental building blocks called templates. They are written in a hardware description language, either Saber's original masked modeling language or the IEEE-compliant VHDL-AMS. The most direct way to create HDL for a template is with a text editor. However, as with any programming language, it can be difficult to adhere to HDL structure and syntax requirements. The StateAMS tool is a graphical front end that generates the HDL for defining new templates for SaberRD. Regardless of your skill level or the complexity of the model, StateAMS is the best way to begin creating a new template. To get familiar with the interface, we begin by creating a simple resistor with StateAMS. Under the Model tab inside the Modeling Tools palette, the StateAMS tool is selected. Pressing the New Model icon clears the window. 2 electrical pins are required. Selecting the Add Branch terminal brings up the dialog box. The first pin is given the name P, and its nature is set to electrical. Another pin named N is added. The P pin is selected and dragged to the left side. The resistor's operation will follow Ohm's law. The plus button is selected to define a static variable for the resistance. A static variable is a parameter which is passed into the template and does not change during a simulation. It's given a default value of 1K ohms. The voltage across the resistor is specified by pressing the Add Across Variable button. With the plus sign displayed at the tip of the mouse, the pin labeled P is selected. Now a minus sign is displayed. Stretching across to the pin labeled N sets the negative reference for the voltage. Upon selecting the pin, a dialog box appears for adding a continuous variable. It's given the name VR. All the other information is correctly inferred from the pins that were selected. Finally, the current through the resistor needs to be defined. Pressing the Add Through variable puts an arrow at the tip of the mouse. Clicking the first P pin and then the N pin gets the direction of the current. A dialog box appears for a continuous variable, and it is given the name IR. An analog equation describing the current in terms of Ohm's law is created by pressing the plus button and selecting All from the submenu. This means the equation is to be used with all states, but in this case there is only one state. Using the previously defined variables, Ohm's law is typed in. Pressing the View HDL Code button displays the masked HDL that has been automatically generated. Bringing up a local menu, the code can be changed to VHDL-AMS. The template is saved. An instance is put into the schematic by clicking the Place Part button and moving the window aside. Additional StateAMS examples can be found under the Help menu and Tutorials submenu. We'll take a closer look at the analog switch example to see how templates with multiple states are defined. The analog switch has 2 electrical pins and a digital input to control the switching. Pressing the Add Initial State button and then clicking in the state diagram window creates a bubble for the off state. Clicking the right mouse button or escape button exits the Add State mode. Pressing the Add State button and clicking in the state diagram window creates a second bubble for the on state. Transitions need to be added between the states for both directions. Clicking the Add Transition button shows an arrow at the end of the cursor. Clicking on State 1 and then State 2 puts in a transition arrow. Another is added in the opposite direction. A right mouse button click exits the Add Transition mode. Clicking Zoom to Fit fills the window. With the diagram drawn, it's time to define the states and the transitions. Double-clicking on S1 displays the Edit State dialog box. The name is changed to Off. An analog equation is added for the current that defines it as the voltage divided by the off resistance. The on state is defined in a similar fashion. Double-clicking the question mark of the off to on transition brings up a dialog box. The condition for transition is defined as when the control input, labeled C, is equal to 1. The default transition time of 1 microsecond will be used. The opposite condition, when the control input is equal to 0, defines the transition from on to off. Clicking the View HDL button shows the template that was generated. Selecting the Check Syntax button verifies that this template compiles correctly in Saber with no syntax errors. This concludes this section of the SaberRD online training course. To download a free student version of SaberRD, go to the Synopsys website. To further your understanding of this material, go through the lab exercises found at the link listed in the description of this video.